talk about annuities still, but we're going to actually talk about the present value. So there's a big difference in like the present value and the future value, because for the future value, which we just touched on in 8.4, we're focusing on making payments now or making investments now, and how much is it going to be worth in the future. For present value, what happens is this is more like the loan type, or it could actually even be an investment where you're pulling out regular installments. So we know, for example, in a car loan, you borrow $20,000 right away. And then, so that's the present value. And then you're going to make payments and payments and payments. Eventually, it's going to go down to zero, right? Or the other style is, so a lot of people have pension plans, but a lot of people actually don't have pension plans. The way you can give yourself a pension plan is there are companies that you will go to and you can say, here is $500,000. Okay, invest it in whatever you want. And what they're going to do is they're going to actually give you a pension with your own money. They're going to guarantee X amount of dollars, whatever it is, for so many years, for example, like because they have like a certain interest rate and you give them a certain amount of money. Okay, so then eventually your investment is going to deplete to zero. So that's one of the styles that not a lot of people are so familiar with. Okay, so present value of an annuity is the amount that you would have invested today or borrowed in order to receive or pay a certain amount of payments after a certain amount of time. Okay, again, we're talking about regular intervals, so that R. Okay, here's the equation. PR, again, present value. R is going to be the regular payment. I is the interest rate, and of course that's in a decimal. And again, the interest rate is going to be divided by the number of compounding periods per year, because this is just the interest rate per compounding period. And then the N is going to be the number of compounded periods. So you take the year, multiply it by the number of compounding periods per year. Okay, so same idea. Okay, Dan wants to make an investment so that he would receive $4,000 every 6 months. Okay, so this is 2 times a year, times 2, for 5 years, with the first payment due in 6 months. Okay, you're always going to see this. This is going to always align with this. Okay, so how much money should he invest now? He's going to get 7% a year, compounded, of course, semi-annually. So again, this semi-annually is always going to align with that, like 6 months. Okay, let's write down everything that we have. So he wants to receive $4,000. So that's kind of like a pension, right? So the regular payment that he wants to receive is $4,000. Okay, the interest rate 0.07, but it's twice a year. And then the number of years is 5, but again, it's twice a year. So he's going to get 10 payouts, and 0.07 divided by 2 is 0.035. So 3.5% per payout. And then what we're actually looking for is the present value. How much does he have to give that insurer or that investment person so that he's able to do this? Let's sum right in. So R, we have $4,000. Okay, 1 minus 1 plus I. So we have 1 minus 1 plus I, and that's raised to the negative n. So when we talk about negative n, what we're doing is we're making that basically decreasing. 0.035. Okay, so remember negative n, it'll bring it on the bottom. So like we'd be basically dividing 4,000 by whatever this is because of that exponent. But we don't even need to know that. We're just going to walk through basically the calculation. Let's do this entire bracket. So we're going to do 1.035. Let's raise that to the negative 10. But then okay, so this is where a lot of students make a mistake. So it's 1 minus this. It's not this minus 1, okay? Because 1 has a positive sign on it, and this actually has a negative sign on it. So it's going to be actually 1 minus 0.7089188. Okay, so we're going to do this in 2 steps. So let's go. 1 minus 0.7089188. Okay, here we go. 0.2910812. Okay, I'm going to multiply that by 4,000, and I get 1164.32 and change, and then I'm going to divide it 0.035. So 33266.42. So therefore, Dan needs to invest $33,266.42. Let's just say right now. Right now. Okay, so right now, like the present value, right now, and that's in order to take out $4,000 twice a year for the next 5 years. All right, example 2. Len borrowed $200,000 from the bank to purchase a yacht. If the bank charges an interest rate of 0.066 compounded monthly, and he will take 20 years to pay off the loan, so 20 times 12, how much will the monthly payments be? So, and sometimes if I don't know the difference between like the PV and the R, as soon as you see payments, it's R. So therefore, the 200,000 is the PV, the present value. Okay, and let's go ahead and let's go 0.66 divided by 12. I get 0.0055. And let's go 20 times 12, and I get 240. And again, this one is just a simple sub-in. Okay, we don't know the R, so we're going to solve for the entire bracket here, and then what we're going to do is we're going to divide both sides by it. Okay, to the minus n, negative 240, and then we're going to divide by I, and I is 0.0055. Okay, my calculator is really good. I'm going to put this entire top in. And 1 minus bracket 1.0055 bracket to the exponent negative 240. Okay, I get 0.731896788. That's my entire numerator. If you can do this in like one step, you can just leave this in your calculator and then divide it out. So I get 200,000 equals R times, let's go 133.0721434. And let's actually divide out both sides. Okay, 133.0721434. 133.0721434. Okay, so I get the payments are $1,502.94. Okay, so therefore, Len needs to make payments of $1,502.94 to pay off that $200,000 loan for that yacht. Okay, and how much interest will he pay over the term of the loan? So here's the thing. Interest, we have an interest rate, but we also have the payment of $1,502.94. And if we multiply that by the 240 payments, what we get is $360,705.60. And all we have to do to solve for how much he paid in interest is subtract the 200,000. So he paid a lot of